Hi, my name is Avery Ash, and for this week's interactive case study, we are going to be talking about the drug oncovin. Before we get to talking about oncovin, we need to talk about tubulin. Tubulin is a protein that polymerizes into long chains or filaments called microtubules. Microtubules are hollow fibers that serve as the skeletal system for living cells. And here I have an image of tubulin. This is what forms the microtubules. Microtubules can shift through various formations, and this allows cells to go through cell division or to regulate intracellular transport, and this is made possible by the flexibility of tubulin. Microtubules are critical to cell division as they are the pieces that attach to the chromosomes and pull them apart towards the cellular poles. So without microtubules, you don't have division. In chemotherapy, since cancer, all that it is just uncontrolled cell division. And so the goal of any chemotherapy drug is to stop cell division. Cell cycle specific drugs affect cells only when they're dividing, while cell cycle non-specific drugs affect cells while they are at rest. Chemotherapy works best against chemotherapy works best against cells that are rapidly dividing, so there's more cells dividing, so they have more of an opportunity to stop it in its tracks. Drugs, unfortunately, they can't differentiate between normal cells and cancer cells, and so this can lead to side effects for the patient due to damaged healthy cells. Now, oncovin is one of these chemotherapy drugs. It's classified as a plant alkaloid, which means that it is made from plants. The plant oncovin comes from is called vincristine, which I have a pretty flower here, vincristine. Oncovin is cell cycle specific, and it disrupts the cell cycle by inhibiting the microtubule structures within the cell, which stops cell division and ultimately leads to cell death. Oncovin inhibits the microtubules by binding to them irreversibly, and this interferes with the flexibility. And this stops the mitotic spindle from forming and attaching to the chromosomes. This binding occurs during S phase, and it halts the cycle forever in metaphase. And cells can't exist in perpetual division state. They either have to complete mitosis or die. So once oncovin attaches itself to the microtubules, the cell is going to die. And that is how oncovin can help treat cancer. And here are my sources. Thanks for coming along with me on this journey, and have a good night.